First things first, time for selfie.
All right. So let's get it started. How is it going? Are you enjoying the conference? Hands up. Good. Are you?
Yeah, of course.
Great. We are here to talk about how to test your message application. But first thing first, a small disclaimer. We are going to use Java and Spring, but the problems and solutions we are going to show today, these are, I would say, technology agnostic,
Absolutely.
right? So we are going to use Java and Spring, but those problems apply everywhere, and solutions as well. Why we do this presentation? We have a feeling that as an industry, we don't talk much about how to actually test properly your messaging-driven application. We talk about how to test HTTP-based APIs, things like that, but we don't spend much time on message-driven APIs, right?
Correct.
That's why we do this talk. My name is Jakub Pilimon. I work as developer advocate at Pivotal, and the slides don't work. Sorry for that. All right. I'm mainly interested in domain-driven design. I like to talk about architecture and test-driven development. I have a Twitter handle. It's @JakubPilimon, and I have a blog. I blog occasionally, I would say, and I'm a co-founder of DDD by Examples, which is a pet project. If you would like to collaborate with us, find us at GitHub. It's basically a set of samples that aim as a bridge between people who would like to model some domain according to domain-driven design principles and rules, and then back it up with Spring, for instance, in the infrastructure layer, or maybe in PHP, because we are going to have PHP samples soon too. All right, I'm here today with Marcin.
So, hello everybody, my name is Marcin Grzejszczak, and I work also at Pivotal for the Spring Cloud team. I am leading the projects called Spring Cloud Sleuth for distributed tracing and Spring Cloud Contract for contract-based testing. And I'm also extremely fond of CI/CD topics. I run such a project called Cloud Pipelines. My Twitter handle is @mgrzejszczak, and my blog is toomuchcoding.com.
Great.
Yeah, so let's get it started, and let's imagine for a second that we are in a company where I am an ivory tower architect. So I haven't been coding for quite a few years now. And the business told us that we have to develop some new features. We have an extremely small budget, so the only person as a consultant we could afford is Jakub. So he's in our company as a consultant. Jakub, thank you for joining us.
Anytime, Marcin.
Maybe
Anytime.
I'm going to tell you a few things about what we do here in the company.
Maybe you'll show me some code, because, you know, the code speaks more
Yeah,
than
that's
1,000
true.
words.
I'm going to show you that in a second. So in general, we are a financial institution that grants cards.
All right.
So let's take a look at the test that will tell you how exactly our application works. So it's a Blackbox test. A request comes in, and there's a response out, right?
Is the font big enough, by the way? Hands up if yes.
Good.
Good.
So we have two scenarios. If somebody's born in the 70s or later,
All right.
that person's going to grant a card. We're going to grant the card to that person, right? So a request comes in with a person with a personal ID starting with 70, which means that this is the year of the birth. Then the response is successful, right? And if the person is born before the 70s, the response is unsuccessful. You can see that the personal ID starts with 61.
It's like a sophisticated risk check.
It's an MVP risk check.
All right.
That unfortunately went to production. Let's go to the controller.
In here, I guess,
Yeah.
right?
So this is our, let's say, HTTP controller that delegates some work to the application service.
Okay. If the card was granted, we return OK. Otherwise, forbidden. Okay, let's go in here.
So now, what we're trying to achieve in our fabulous company is to have a self-documenting code. Can you actually try to read what most probably this code does?
So it applies for a card. If the person was born before 70s, then I guess the card is not granted.
Correct?
Correct? Otherwise, you create a card with a default limit, you save it, and the client actually got the card.
Correct. And to the bottom, you can see our sophisticated rule engine to verify if somebody's a fraud or not.
All right.
So now, so this is the current state of things. And we have another application called a notification service that, believe it or not, but notifies clients about different things.
Via email, via text messages?
Exactly, correct. So the thing is that what the business wants is that when the card is granted or not, we ping the notification service and say, hey, can you do something about this, notify the client that the card was granted or not.
Or the person was actually rejected, right?
Correct. The thing is, out of my extensive experience, I'm pretty sure that the business doesn't even know what they want. There's one thing. And the other thing is that most likely they will try to notify more services. Mm-hmm. So we will need to build some sort of a solution that will allow us to, send messages out to various services, informing them about the state of things.
Would you like this process, actually, of granting or rejecting card to be, down-performing if other services down-performing? Would it be affected?
Yeah, so the thing is that whatever we invent and the business wants, the process of granting cards needs to be stable. Right?
Right.
So if the notification service is down-performing or is down at all, it cannot do anything with the process of granting cards.
Makes
right?
sense.
And
any solutions?
Yeah,
any ideas?
I don't even know why you're here because I will show you how the professionals would solve this problem. So can you step aside and see how the things should be done? So over here we have this situation where we reject that person, right?
All right.
So I would send an HTTP call to a service that the client was rejected.
You mean to the notification service, right?
For example, right? And all the other services. And here that the client was approved, right? Let's say. The client, the card, right?
All right. What happens if there is another service or a set of services that would like to get this information?
Oh man, I can see that you're a very, very young consultant. This is obvious. Do you know the shortcut IntelliJ Command D? So you just copy-paste, and this is how you add more services.
So the more lines of code, I guess, the more money you get, right?
We're paid by the lines of code, so aren't you?
So what happens if one of them is actually down or is down-performing? Would the process of granting or rejecting the card would be affected?
There are solutions to this challenge. For example, we could use a circuit breaker.
And what about circuit breaking? How are we going to ensure actually that the message will be eventually delivered? Because I guess it should be delivered at the end.
I went to a conference and they said something about circuit breakers. This is why I just remember the name. But yeah, if we should use a circuit breaker and we don't send the message, still we would have to store the information that we tried, and then we would have to
the other downside is that the more services you have, the more lines of code you have to write, which means you have to test this process one more time, you have to modify it. It violates open-close principle, I would say, right?
We are paid to write business value, not to write tests, right? So that's not a problem.
All right. So how about a different solution?
Okay.
I'm a professional, you know that, right?
If you say so.
So before coming here, actually, I was going through your code base and your architecture, in a nutshell. And I have seen you are using some sort of messaging infrastructure.
RabbitMQ, yes.
So you are familiar with messaging, how does it work, etc., etc. Yes. So how about, instead of notifying all of the services one by one, we are going to notify one thing, which is a message broker, that something has happened. So you are going to send a message saying that something in the past, which was important, business-wise, has happened. It's called an event, because from the past.
Okay, so you're saying that we do this instead of knowing the name of every single application and their endpoint and the method, HTTP method that we should call. So instead of doing that, we'll just send out a message.
Yeah,
okay, that sounds good.
You already use this kind of solution in the same code base, by the way.
Okay, let's do it.
Did you know about
that? I heard about it. So can you, let's say, recap why we should?
One more thing, because you are going to delegate this work to one component. You are familiar, I guess, with delegation.
Oh, I love delegation.
So
I delegate all the work I should be doing to some other people.
You're going to delegate this work to a message broker, and you're done.
Perfect.
How does it sound?
Let's do it. Delegation is the key.
So let's recap why actually you might use messaging in this specific case. Are you familiar with something which is called temporal coupling?
Coupling related to time, I guess?
Great. which means that if two applications, if they want to communicate with each other, they have to be alive at the same time. Otherwise, there is no communication, right?
Yeah,
like,
makes sense.
For instance, with basic HTTP call.
Okay, makes sense.
With messaging, it's not the case, right? Because if the consumer is down, if it's a durable subscriber, the message broker will deliver the message afterwards, right?
Okay.
Does it make sense
Yes.
so far? Cool. Also, the consumer can consume the messages at its own pace. So we are not going to overwhelm the consumer from the producer side, right?
Okay.
The producer doesn't care. Make sense?
Yes.
Broadcast, multicast. So the more services you have, to notify about something that has happened in your granting or rejecting process. Actually, you don't need to modify the process because you need to actually subscribe to the topic or to the queue, whatever you use. Make sense?
That's a good idea, yes.
Plus, there is something which is called spatial coupling, which is gone. Spatial coupling means they don't need to even see each other in the infrastructure. I mean, the producer doesn't need to see the consumer and vice versa. They don't even need to know about each other. Like the producer doesn't know who the consumers are. The consumers, they do not know who the producer is, which is the first basic principle of messaging.
So service discovery wouldn't help us here, right? Because still, even though we're going to get some sort of an instance of an app, we still have to know the name of that instance. We need to know the endpoints, etc. Okay.
You don't need to know the physical address, but still you need to know the logical address. With messaging, it's gone.
I like it.
You have no idea, right? So how about we try to implement this feature with messaging,
Let's do
right?
it.
So as I said before, you have already started some work regarding communicating with message broker via events. And you have this interface somewhere in here, which is self-documented, by the way. It's an interface.
Can we read the Java docs?
It's a domain event publisher, which has one method, which is called publish.
Okay.
A domain event, which publishes domain events, etc., etc.
These are good docs. I like them.
Yeah, I thought you were the author, by the way, of this.
Most likely I am.
So we are going to use this to contact our RabbitMQ instance. All right?
Okay.
So we are going to start with what? Any ideas?
It's Spring, right? So
Yes,
with
use
an
Spring.
annotation.
Not this time.
No.
Maybe, how about starting with a test?
Oh, yeah. Sorry, test.
Do you test your code base?
Always.
Always.
Always. Yes.
So I'm looking for a unit test of this apply for card service. It should be somewhere in here. Oh yeah, it's here. It's empty, by the way.
Speaking of tests, we do TDD. So we know the cycle, red, green, refactor, but we do only green. So we write tests that are empty.
These are green for the very beginning, right? All right. I'm an old-fashioned consultant. I do that the whole cycle. Okay, let's do the whole cycle.
Okay.
So what do we need in here? We actually need not only the repo for credit cards, but we need the other collaborator, which is going to be the domain event publisher, right? Make sense? Publisher. It's going to be a mock. Do you know the difference between mock and stub?
So a stub is just an object that you teach how to behave, right?
All right.
You stub out some method calls. But a mock, you can do that, but you also verify if certain calls were made.
Correct. You are a fast learner.
That's what I do.
We need to inject the domain event publisher in here, right? Domain event publisher. Let's call it publisher. Add the constructor. Okay, we are done here. And here we are going to do what? We are going to simulate someone is applying for a card and the person was born in 70s, right?
Okay.
Like this. Is good enough?
Yeah.
And then, if that happened, we are expecting, in fairness, that the publisher was called, right? And it's a method called publish what's called. And the argument is actually instance of what? Of card granted event, right?
Since you're writing a test in Spock, I understand that the last line and then is actually like an equivalent of Mockito verify.
Yes.
Okay.
You use Mockito in your code base as well.
As well, we are full stack developers.
You're gonna see that. Yeah. You're gonna see that soon, right?
Yeah,
you have Spock, you have Mockito, you have Selenium, you have everything.
Yeah, we're full stack.
Yeah, full stack developers. All right.
This is easier to recruit people, you know.
I know. So in other case, I will do copy pasting. You are familiar with this?
I love this technique.
So 57 card application granted, not granted, but rejected in this case, right? That should be red, of course, right?
Oh yeah, because we just injected.
Remember the whole cycle:
yeah,
red, green, refactor, blah blah. All right, too few invocations. That's good enough. Let's actually fix that. In this case, if the person was born in 70s, we are going to publish what? A new card application rejected, and it takes client ID as the argument, right?
Okay.
And the other one is card granted, and it takes what? It takes, I guess, number, it takes card limit, and it takes the ID as well.
Good.
It compiles. Let's rerun the test. If these are green, can we go to production?
Of course.
Who thinks we can go to production?
Who wants to commit, push with force, and go to production? Okay, there are some people.
So actually, can we go to production? What are
wait
your
a second.
thoughts?
Wait a second. Because the test passes, but have you actually implemented? Because I didn't. Have you implemented the domain event publisher interface?
I have not.
Okay.
So clearly, this test is not enough.
Yeah, it's a good start.
It's a good start. It's a very good test, but there is no implementation of domain event publisher, and we cannot catch this fact from this test, right? So what we need to do, actually, first thing first, we need to implement the interface and write a test for this implementation, right?
If you say so.
So let's create an implementation of this. Implement interface, use Rabbit, right?
Yeah.
To RabbitMQ event publisher, I will name it like this. Good. Yes. I think it should be public. So how we are going to contact Rabbit, by the way? Have you heard about this framework called Spring Cloud Stream? Does it ring a bell?
Yes, it does. So I went to a conference and they said that Spring Cloud Stream is a framework that abstracts your code from the underlying broker, underlying infrastructure. So it has notions of channels. So you send out a message to a channel, or you pull for messages from a channel.
Good.
And now, depending on what you have on the class path, it knows how to actually translate it to some broker language, so to speak, right? So whether it's a topic or an exchange or something like this, right?
So first thing first, I need to somehow define the number of the channels we are going to use in our application.
Correct.
And we do it with add enable binding. Definition of the channels is, in this case, source, which is just one output channel.
Yeah, because Spring Cloud Stream comes with a couple of interfaces out of the box, because typically what you're doing is you send out a message, or you just poll for the message.
Or you do both.
Or you do both, then you're a processor. You have a source, which is for sending out messages to some destinations, or a sink if you're polling for messages, right?
And thanks to that, and thanks to class path scanning, we're going to see the driver to RabbitMQ. We are going to map the output channel to RabbitMQ Exchange.
Okay.
Right? So how we are going to actually contact the message broker in here? So what we can do, first option is we are going to use the definition of the channels. I'm going to inject them in here. All right?
Let's do it.
Private final source. This one, good. Add constructor, and here what? It's super simple. I'm taking the first channel, the only one which is there, by the way, and I'm sending a new message. It's going to be a new generic message, and the event is the payload, right?
Okay.
Are we missing something?
You know, in HTTP, we have the headers, right? So, for example, you can say, what's the length of the message, what's the type, etc.
Some sort of metadata,
different?
right?
Yeah. Do you have something similar here?
Yes, you can pass headers so that, for instance, the consumer, they don't need to actually parse the payload because they can check the headers, what's the type of the message.
Okay.
They can discard the message if they are not interested, right?
Yeah.
So let's pass the headers as a second argument, which is, by the way. Huh?
Ooh.
Nice. Headers.
Nice.
So I'm passing headers as a second argument. And that's it. We forgot about test, by the way. Right?
I didn't.
I did forget about testing, so it should be somewhere in here. As I said, you are full stack, so Spock, JUnit, Mockito, whatever else.
You know, we make bugs in all sorts of frameworks and languages, so.
Correct. So this is a fully blown integration test, right? It's going to bootstrap the whole context of our application, so the main event publisher will be there, etc., etc.
Okay.
So we are going to Blackbox test the application and see if the event was emitted or not.
But do we actually want to contact Rabbit in this test?
Yeah, you're right. So we shouldn't contact Rabbit in the integration test because we cannot rely on running RabbitMQ instance on this machine right now. What can we do?
Let's mock it.
Let's mock the
bean.
The main event publisher.
Yes.
So I'm going to pass mock bean, right?
Oh, that's a good annotation.
The main event publisher, right? And now what? Now, whenever someone actually applies for a card, and the person was born when? In 70s, right? Then what? Then we expect, and now we use Mockito, right? To verify that this component called domain publisher was called. In particular, its method called publish with an argument which matches this. It's an instance of card, in this case, it's granted, right?
Yes.
All right. Oops. Now it's better. Let's fix this. Copy paste again, and we change what? The actual year and the expected event that should have been emitted. Card application rejected. Fair enough?
Let's run it.
If it's green, can we go to production?
Of course, man.
Finally?
I mean, we have 2 tests passing. It's more than one,
Like we have 4.
Even 4 tests. That's amazing.
It's green.
Let's do it. Let's go to production.
All right. So, I have this, I'm not proud about this, but I have this habit of,
Tell us.
okay, I run my apps locally before pushing to production.
What? I mean, you start your app and you click it?
Yeah.
You have a QA department that does it.
I sometimes do that. Right.
Yeah, I would like to apologize. I mean, he's a young fellow. He just starts his career in the industry. He doesn't know what he's really doing.
Plus, I need full hour to be paid, so...
Okay, so run it.
All right, let's run it.
I mean, obviously, everything's going to work because we have passing tests, and it's an embarrassment for...
Application failed to start.
I wonder what it means. Can you copy-paste it to Stack Overflow?
All right.
Application failed to...
Maybe we can just read the
Yeah,
description.
okay. Parameter 1 of constructor in apply for card service required a bean that could not be found.
It's the first time I'm reading that by the way.
Interesting.
Okay, consider defining... All right, so there's no bean.
What does it mean there's no bean? I mean, the tests were passing, right?
Wait. All right, so I guess...
Why is it gray?
Yeah, I know why. It's not registered as a bean, right?
Oh.
So shall I pass some annotation?
Yeah.
Like component?
Can you pass more? Maybe like repository service?
Just to be sure.
Yeah,
all right.
yeah.
All right. Service, repo,
okay.
read only, entity.
Yeah, that's good.
That's good enough? Okay. All right,
Yeah.
so, let's start with the first one and see if it works, right? And then, if not, we're going to keep adding. This is how we do it, right?
You ain't gonna need it, right?
Yeah.
So you start with 1. Okay.
Oh yeah, you're right.
Okay.
All right, so if I rerun this application locally one more time,
it should work.
Let's do it, okay?
Okay.
You good with that?
Yeah.
Good, right. So I'm rerunning the app and let's see if it works this time. Hopefully, if it works, can we go to production?
Of course.
All right. I need full hour, as I said. But the test, why it was green, by the way? Like, I don't get it, in fairness. Like, it should have been caught during this test, right, that there's no bean.
I don't know.
Any ideas?
No idea. Maybe Google it.
Jitter?
Yeah, maybe. We have to ask somebody from the Spring team.
So mock bean domain even publisher. It was mocked, so it should be good. I'm going to do something insane.
What?
I'm going to read the Java docs of mock bean.
Read the what?
Java docs. It's like a documentation.
You don't do it. You just ask people about stuff. You don't read the docs.
I don't have time.
Okay.
Man, we have like half an hour. So mocks can be registered by type. Any existing single bean of the same type, blah, blah, blah.
Will be replaced by the mock, which is
That's
expected.
obvious, right?
Yeah.
If no existing bin is defined, a new one will be added.
I don't know about that.
So that's by
Okay.
nature of this component, so that's our fault.
Okay.
Good thing we read the docs, right?
You know what? I remember one thing, because when I went to this conference and I heard about Spring Cloud Stream, I heard that you have this idea that you have the code and you have the infrastructure that gets the messages, right?
You mean the application core in which you define the channels and then the binders to those channels?
Correct. And there is a test binder that you can use for tests, which means that you can use in your tests exactly the same production code as used on production. And you can store the messages that you send in a Java util queue.
And then you can assert this queue, right?
Correct.
All right, so you can just bind the channel to the Java blocking queue. I'm going to do so.
Yeah, and that way we don't need to use any mocks.
Correct. So how to do that? You need to auto-wire the message collector, which task is to actually collect messages, by the way.
That's a good name.
And you need to define the blocking queue, which is like a simulation of the RabbitMQ exchange, Kafka's topic, or whatever binder you use in production.
Okay.
All right? And then you need to actually define or inject the channels that you are going to use in the application. And you have to teach the framework that, you know what? Here, please store all of the events that are emitted to this channel called output.
Great, and we can assert those messages. That's a perfect thing.
So you know what I'm going to do? I'm going to copy-paste from the previous test. And when someone applies for a card, and the person was born in 70s, right?
Correct.
Let's change it to 70s. Then we can actually go and check the events blocking queue. Let's do so. Events, we can actually poll the last message that we expect to be there. What can we do? We can check its headers, for instance,
Okay.
and see if the correct header is there.
Oh yeah, because in the headers you provide the event type.
Yeah.
Right,
Yeah,
okay.
yeah. Remember from the publisher
Yeah, I
here,
do.
right? All right? Good.
Yes.
So, okay, let's do the same for the second test. In this case, we are expecting a different header for a different client.
Card
The
application
client-
rejected, right?
Yes, the client was born in the 50s, application rejected, right?
Correct.
Fair enough?
Great.
It should be green or red.
Green, as always.
If it's green, can we go to production?
Of course.
Let's recap first. If it's green, of course. Let's wait. Fingers crossed. Green.
Green.
Good. So let's recap what we have done so far. By the way, while you were talking, I sketched the whole architecture of your application. It's that simple.
So you're saying I'm not special.
Yeah, and you hire a consultant to do that. All right, so you have the controller, you have the application service, you have the entity, you have the repo, database, and then you have this new domain event publisher.
Okay.
Then you have the message broker and the set of apps which are subscribing to the specific messages. In this case, it's just a notification app,
Okay.
right? The first test that we have written, it took in isolation the apply for card service. We did a unit test, which is very fast. It gives us a fail-fast feeling, right? It can test the business logic depending on the conditions if we emit proper events. That's
Correct.
a good test.
Yes.
We have used TDD. It led us to a good design, etc., etc.
Yes.
You should have as many of those as possible.
Makes sense.
But then on top of that, domain event publisher is not tested, right?
Yeah.
And even though there is no implementation, the test passes, so we need something more. So we came up with this idea of Mockbean, which actually was an integration test with a Mockbean that bootstrapped the whole context with the MVC, even in-memory database in the form of H2. Probably we should have used text containers, something like that.
For example.
So we took the whole application, but then we mocked out the thing that was about to be tested in the first place. Like the whole purpose of this test, and that's a common mistake, was actually to test this behavior, and we mocked it out. So it's useless, right? It's longer than the previous one. It gives us false positives, etc., etc. So let's forget about that.
Okay.
But then we actually have tested the domain event publisher itself because we have used the tool provided by Spring Cloud Stream, a testing binder, and actually the whole application, the production code, it's in the testing phases as well. Does it make sense? So
Absolutely.
far? So what can we do right now?
Go to production.
Before that, one more thing. So the first application, it's running, right? Other thing that I do before actually pushing to production is sometimes, just sometimes, it's not always, but sometimes I just start the second application and the RabbitMQ instance, and I check if they actually can communicate.
Before you push the code to a branch or to master branch, you check if things work fine.
Sometimes I also run tests, things like that.
And say, okay, go ahead. You're young.
Would you
You're
mind?
going to change.
And I have seen that you already have started some work regarding this consumer application, right?
Yeah, it's an MVP that, of course, went to production.
Yeah, it's in here, somewhere in here. Can you briefly describe what does it do? Like, what does it mean, this add stream listener?
Yeah. So this is the notification service, right? So it listens for messages. So it's a stream listener, right, essentially.
Makes sense.
So it has two methods. One that was going to be activated when a message with a header type card granted will be received. And the second one is when the card application rejected will be received, right? So we have two messages. You can see target sync input, which means that this method will be activated when a message comes into the input channel from the sync interface.
With a specific condition, right?
Correct.
As you said. All right, so in the meantime, I have started this application, so both of them are running just by accident. It's coincidental, but RabbitMQ is running on this machine right now.
Okay.
So we have three things. If I do HTTP PI or curl or something like that to the first application, that should emit one of the events to the Rabbit, and the second app, which is up, second app is up, that should actually get the message, right?
Yes.
So let's do so. The two apps are running. Let's do something like this. Make sense?
This is 43, so it's before the 70s. Okay.
Yeah, the content is client ID born in 40s.
Okay.
That should be 403 HTTP,
yes,
right?
Correct.
Correct?
And it is.
So if I do right now something like that, where is that?
Okay.
In here, in 70s, that should be HTTP 200. And we should see two log statements in the second app.
Yeah.
It's 200. Let's go back to the log statements. Rejected, granted. The order is correct. I think my job is done here. I will send you my invoice. Thank you.
You're going to get as much money as it's there in the bracket.
It's not even a number.
That's what you're going to get. Why is there a no there?
I don't know.
You know what? I'm a little bit fed up with how you work. You know, you constantly delegate problems to other people. Who are you going to blame
it's not
this
my
problem to?
It's not my I don't think it's my fault.
Okay, give me the name. Whose fault is it?
You want the actual name?
Yeah.
It's gonna be, I would say, Jackson.
Jackson.
Yeah.
Like Peter Jackson, Michael Jackson.
No, Jackson. You know.
Jackson the serializer,
framework,
right? Jackson the framework.
The framework, yeah.
Is the name of a TV series?
You know Jackson, the framework. Yeah. It serialized purges to JSONs
this
and the other
one.
way around.
Yeah. I didn't configure it.
So it's your fault. It's Grzejszczak's fault.
But doesn't it work out of the box?
No. I mean, it can be, depending on the purges that you are going to send. So let's actually take a look at the purges from the producing app. It should be somewhere in here. We are looking for card application granted, or rejected. Yeah. And you are the author, by the way. So it's your fault.
Oh, yeah. Oops.
This guy.
So you're saying that since I didn't configure anything, I need to add the getters, right?
For instance, yeah. It's not a business object, so you can actually do that.
Oh, okay.
Private final string client ID. Add getter. So if I rerun the producer right now.
Oh, you're saying that the message was improperly sent? Okay.
Yeah, that's my assumption. I'm going to test that by doing the same exercise one more time. So let's rerun the producing app, and let's do the rejection, so HTTP 403, one more time.
Okay.
And see what is in the log statement in here, right? Good. Let's go back in here. We are looking for this, right?
Okay.
403. Good. 403. Let's go back. Yeah.
Okay, so we have the number there. You know,
you can see that's going to be on my invoice too.
I don't think so. So this is actually good, but I don't like the fact that we have had to restart the whole thing to verify if things actually are working fine. That we have to run the apps.
What if we had 5 applications?
Yeah.
In fairness,
and a mainframe.
You're right.
What can we do?
So let me think about that. Now I kind of regret that we haven't used, HTTP-based communication, because if we had used HTTP-based communication, then there is this thing which is called consumer-driven contract. There's also this guy talking about this everywhere, always.
Okay.
He's very boring, by the way. So I have attended his conference 2 weeks ago. I couldn't handle it till the end. But he was talking about HTTP all the time. So anyways, it's not going to help us because we are using messaging.
So let me interrupt you.
All right.
First, he's extremely awesome. That's the first thing. His talks are great. And if you stayed until the end, you would have known that you can also use this approach in terms of messaging.
You mean consumer-driven contract with messaging?
Yeah, so Spring Cloud Contract, the presentation was about Spring Cloud Contract. You can also leverage it to verify if your messaging-based communication is working fine.
I guess only with Java, right?
No, you can use it in a polyglot environment as well.
Show me.
Let me show you. So on the producer side, what we've managed to do is we've managed to define contracts. And there was a presentation here about not to use YAML.
Yeah.
This is why precisely we're going to show you YAML. But you could also use Groovy, which is something I prefer because I never remember the syntax. And I prefer the compiler to tell me what exactly the syntax looks like. So let's not go into big details of this. What you're doing in this YAML, essentially, is you define, as the producer, I'm going to send this message out, right? And the message has a body, headers, etc., and is sent to a particular channel, right? Does it help us in any way?
It's just YAML, man.
It's just a text, right? So what happens is, and Spring Cloud Contract does it, it's generating tests out of it. So if you check this out,
Interesting.
if you check this out, you'll see that we have a generated test. So not a person didn't write it.
I have a question.
Yeah.
What does it mean, send rejected?
So when we generate those tests, we need to set up some sort of a context before the tests are executed. So in the case of send rejected, what happens is we need to somehow publish a message, right? Because on the producer side, we want to publish a message and see if it's properly serialized, right?
So we need to trigger the behavior.
We trigger the behavior by sending out via the domain event publisher, so the 2Rabbit MQ event publisher, we're sending out a card application rejected message.
All right, show me if the test fails because, we talk too much.
Okay. So if we go back, if we click somewhere, where's the mouse? Oh, here. If we do run.
I mean, that shouldn't fail because the client ID is there. I added the getter, but the timestamp.
Oh, so something failed, right? So we managed to pass the assertions on the headers, on the client ID,
Nice.
but there's no timestamp.
So you're saying that if I go ahead and add the getter for timestamp or configure Jackson and rerun the test, it should be green?
Correct.
Let's do that. So it was card application rejected, right?
Yes.
So this one, I'm going to do the same with the second field, timestamp, create getter, rerun the test.
Great.
Nice.
Now it works.
So actually, I can check if the payload is correctly serialized.
Payload, headers, and whether you've sent the message to the proper destination.
Okay. So not only we have tested the left side of the communication, but we can also make sure with contract-based testing that on the wire we have a proper payload, body, etc., etc. Plus, on top of that, I guess, you can use the same payload, not payload, but the same contract definition on the consumer side, so in this case, client notification app, to actually test if the message was sent, if the email was sent, right, as the result of message being received.
Correct. And it's as if, on the consumer side, it's as if you had a producer application sending you a message. But there's no broker and there's no application.
So we managed to test the whole communication without having to set up the message broker in between.
Yeah. So finally, we can
Good.
commit, push with force, and go to
Nice.
production.
Here is my invoice. But there's, except for the invoice, there's one thing that we did wrong at the very, very beginning, like the first line of code.
So you
literally-
waited until the end.
Yeah, I was
tell
sure
us.
that you would spot that, but what I was thinking. Let me fix that right now. Let's go back to the application service called Apply for Card service. So, do you see any problems with this method?
If I did, I would have told you.
That's right. So, in particular, maybe we are going to see something wrong with this method and with this annotation.
Well, let me
What does
make
it do,
bigger.
this annotation? Add
So
transaction.
it creates a proxy, right? It wraps the method in a proxy, and it starts the transaction before the method is executed, and it commits the transaction after the method is finished.
So where is the actual commit to the database?
After the method, after the return.
Or the rollback happens if something
Okay,
wrong happens,
correct.
right? Okay, so let's think about a few possible scenarios. Scenario number one. You grant the card, you go to the message or the event publisher, you send an event out to RabbitMQ or to Kafka or whatever you use, and the message broker says, I got it, it's fine.
So we try to save the message in the database, the credit card info in the database. We send out the message to the broker, and we've committed the transaction.
That's the happy part. Scenario number two. We try to send the card granted to Rabbit or to Kafka, and the broker says, you know what? I'm not there. Exception is
stuff.
thrown.
So we try to save, we try to send out, we get an exception, we roll back the transaction.
All right, scenario number 3. We try to go to and send the event to the broker. The broker says fine.
Okay.
Then we go back here. We go outside of the body of this method. Our framework, or you do it manually maybe, try to commit, and your database is down.
It's a simple thing. So we try to save, we send out the information that the card was granted, and we don't save it in the database. It's called eventual consistency.
I think it's like a rather extreme case.
Yeah, it's an extreme case of eventual consistency.
I would call it like immediate inconsistency, something like this.
Extreme. That's what I say.
But you're never going to be consistent with that because it didn't happen. You didn't grant the card to the client, right?
Yeah, you're right.
So you see a problem with
that's
that?
a problem, yeah. So what can we do
Any
about
ideas? No, I guess.
No, zero.
So just from the top of my mind, first thing we can do, we can actually rearrange the order of those invocations. So let's go and first try to commit. If that's successful, and only if that's successful, we are going to send message to our message publisher.
Let's do it.
For instance, with Spring, you can do it, I guess, with transaction synchronization manager. We register a callback after a successful commit, right?
Okay.
You have to pass something here. I guess you have to override the after commit method, right?
So only after commit will the methods...
Yeah. So we change the order of invocation, right?
Called, yeah.
First commit. If the commit is successful, after commit is invoked, you go to RabbitMQ or to Kafka or to whatever you use, and you publish the method, right?
Okay. What will happen if we don't commit?
If you don't commit, this won't be invoked, right?
So we will either send it never or once.
So the problem happens that if you actually commit, we are going to invoke this method once,
Okay.
Which is like based on fire and forget. I'm going to try once with the message publisher.
Okay.
If it's fine, then it's fine. If it's wrong, then I don't know, right?
So is it a good thing or a bad
It's
thing?
like you will deliver the message 0 or 1 times, hence it's called at most once delivery. If it's good, I don't know. It depends on what the message contains. I would say you have to evaluate the solution based on the actual business needs. So maybe the message contains some marketing information. That means that probably every now and then you can lose this information, and we are good with that.
Okay.
Probably.
Is there something else we can do?
Let's say that the message contains something very crucial to the process. Maybe the information how to actually activate the card.
For example, yes.
You don't want to lose this information, right? So what we can do with that, I'll just delete this, like that. The method is transactional. If you are backed by a database which supports ACID transactions, you can store more things, right, under one atomic transaction. So how about storing the event itself and the card itself under the same transaction in the same database?
Okay.
Right? Makes sense so far?
Can you show me some prototype? I'm better at seeing things.
All right. I think it should be here. You wrote it probably. Oh, I did that. All right. So on publish, you actually go to the domain event storage, which is backed by the same database, by the same data source as your card entity, and you either store both of the things or none.
So we store the event, right? Mm-hmm. And then, on a scheduled manner, we try to find those that were not sent, and we try to send them again.
Correct. It's called an outbox pattern. Okay. So every now and then, you go and see the events which were not sent, you send them and mark them as sent.
What about this? We have transactional again. Won't we have the same problem?
Yeah, we delegated the problem to a different component.
That's great, but does it solve our problems?
So let's actually examine this problem. What can go wrong? You can actually send the message or set of messages to the message broker. The message broker says, fine, I got all of them. You are good to go and save them in your database as stored, as sent.
Yes.
But then your database might be actually down, so you won't manage to do so.
Yeah.
So what's the problem? The scheduler will pick them up one more time.
So I can send the message a couple of times?
Yes, until actually you are going to successfully mark them as sent, which is called at least once delivery.
Oh, okay.
So you can deliver once, but you can deliver 10 times depending on the conditions.
So is it good? Better than the previous one?
Again, depends. If it's super important, probably at least once, maybe it's better. Plus, one thing to mention is that if the consumer of this method is idempotent, it can deduplicate the messages that it has seen. You can be close to something which is called exactly once processing.
I see.
Not to mistake with exactly once delivery, right? Processing.
Okay. Since we pay you the big bucks, for sure you have some sort of a silver bullet.
It's not that much that you pay me, by the way, but a silver bullet? There is no silver bullet. You can think about different solutions, like you have essentially events and you have the state, right? From which you can derive the other one. Like, can you take a look at the state and see, hey, the state was created out of those 4 events, or the other way around?
No, the other way around.
Yeah, so actually, you can do something different. You can only store the events somewhere, and then based on the events, you can reconstruct the credit card.
Correct.
But it creates a different problem. If you use the same set of events to actually reconstruct state and to integrate with a different component, in your case, it's a client notification app, then you create a high degree of coupling, right? Because it's like integrating via database.
I see.
So you shouldn't be mixing the same events for this purpose and for the other purpose, right?
I see.
Does it make sense?
Yes.
So far? Any more questions? Because I'm going to send you my invoice very soon.
No, I don't have any questions, but maybe the audience has some questions. So I have a question to the audience. Does it make any sense? Who thinks it makes any sense?
It's a very wrong question.
Okay, 2 people, good.
4.
4 people.
5.
Any questions? Going once? Twice? Okay, so if there are no more questions, if there are no questions, go ahead and you're shy, you can approach us and ask us questions. If not, thank you very much.
Actually, the code base